Hello everyone. This is group leveraging AI to identify the KOLs of the future. My name is Mayu. I will be the first presenter in this presentation, and our company is Genmab, and our industry mentor is Jeremy, and faculty mentor is named John. In this presentation, we have introduction of our project and data processing process, and also the GN model web development. In the introduction part, I would like to have a small background of this project. Our company is Genmab, which is an international biotech company specializing in creating and developing of different antibodies therapies for treatment of cancer. And our project is aimed to leveraging AI and data science to identify KOLs. With the analyze, we have some data from we use some open source data to different areas of doctors and researchers, and then training the model to consolidation with Genmab, and then we finally have our KOLs, which is doctor or researchers at this case, to work with our project. And the process of this project, I think, is basically with some questions like, what is a KOL? Well, KOL stands for key opinion leaders, and in our case, is finding the best doctors for you, and how to find the KOL, and how to get the data set, how to train our model, and even how to improve the accuracy of finding the KOL. I think you should have the answer when you finish our presentation. And the data query will be the next paper. Right.
Okay, so hi, I'm Dennis, and I will talking about the data query and the data processing part. So for the first one, the data query, we need to like putting down the data set from some public database. And for this project, the database we use is the PubMed dataset. And also for like doing the machine learning, we also need to have some features for the model to train. And so the features we use will be the number of collaboration in academic and trials, and number of citation trials, and the years experience. And so for the data query part, we're trying to download the data set from the online database first. Next page. Yeah, so this page shows our data query in a block diagram. So first we are trying to use some API from PubMed dataset to put down the data, and also after putting down data, we'll try to clean the data to find out maybe like someone have less than 1 year of experience, then we'll just filtering out, and also we'll try to extract those features using our code in the query as well. Next page. So the next part will be the data preprocessing part. In the data preprocessing part, we need to extract the feature, and also building, since we are using a GN, the graph neural network, and the raw data set could not be the input for that neural network. So we need to build the graph using some features. And in this project, the feature we use will be the number of collaboration in academic and clinical. So next page. So for number of years of experience, we're just counting them to extract the features. But for the graph part, as I mentioned before, we need to use the collaboration part. And to construct the citation graph, we use a Python package called LibreX. And this powerful package have some already defined API for us to input the info of node, and then it can just generate the graph. Next page. And so for this page, the right image is the constructed graph with the citation network, and left part is just an example for our the data set after the data processing part. And one thing to also mention is that since we are dealing with graph, the score we are like calculating will be using the centrality score in the graph itself. Yeah, next page. So the next part will be the GM model, and I will hand it to another person in our team.
Hello, I'm Yizhou. Now I'll talk about the GM model part. The problem can be divided into three parts, which are data structure, KOL matrix computing, and KOL ranking. The first one is data structure. Our data set is a non-sequential graph data structure. Models like CNN, LSTM, and Transformer are designed to handle serialized data, but our graph dataset requires specialized processing, so we opt for GNN to address this. The second one is KOL matrix. Centrality measures are crucial indicators reflecting the influence of nodes in the graph. We selected betweenness centrality, closeness centrality, degree centrality, and years of experience as matrix. Traditional algorithms incur unacceptable computation times when applied to a large-scale graph. Therefore, we are training a graph neural network to feed the BC and CC values of nodes instead of computing them directly. The last one is that our goal is to rank the QVals. So using the BC, CC, DC, and YOE values of nodes, it becomes possible to rank thousands of nodes representing experts. This process allows us to get the top key KOLs. The model is built with 6 layers, which are 5 GN layer and 1 MLP. MLP is multi-layer perceptron. In the model, MLP is designed with 3 fully connection layers, so that at the first stage, MLP integrate features output from the upper GN layers, mapping them to one dimension and output the final score. And normalization, dropout, and radial function is some method to optimize the model training process. Next page, please. So about the model training, the model uses some randomly generated skew-free graphs as the training set. The script generates with number of nodes varying from 5,000 to 10,000. 40 graphs are used for training and 10 graphs for testing. We evaluate the result using a KT score. The KT score measures the similarity between two vectors, with a higher KT score indicating greater similarity as it approaches 1. Next page. To summary, the score is weighted by multiple ranking values. Although it is not absolutely monotone, it is overall monotonous, which demonstrates the effectiveness of our algorithm.
And it's back to me now, and I will cover the web development part. We have our website published. By clicking this link, we should have we have our website here. Sorry, excuse me. In our website, we have a brief introduction of our model again, and you can find how our website works and where our data from, and also the limitation of our data source, of course, and also how our score is calculated, as we just talked before, and also DC, CC means and the value, basically the introduction of our model again, and our accuracy rate. Right now, the highest one is 73%, and some of them are lower than expected, to be honest. And also basic introduction of our website and our paper reference there. And to use this website, you can search by oncology or immunology, which is 2 areas that Genmab focused on right now. And let's just randomly pick one, maybe immunology, and we choose. Yeah. And here we go. Maybe we have more people working more years. And by clicking their names, you can see all their detailed information like their name, their field of study, and also their affiliation right now and their score by after calculated. And also you can see their published papers, and by copy those papers you can search for it and take a look at that. Yeah, basically our website is like that. And also we have our domain, which is findkol.com. You can also visit that to our website. And here's our reference. And thanks for listening.
Yeah, thank you.